Thank you again for being here. I hope you are enjoying the second day of the Humanoids Summit. We are almost ending, but still we have very good speakers. So right now, please let me introduce Prasanna Mantravadi. He is manager at FEV Consulting. And well, welcome Prasanna, thank you.
Thank you. Good afternoon. Hi, I'm Prasanna Mantravadi. I'm Prasanna Mantravadi. I'm a manager at FEV Consulting. Just wanted to, today the topic that I want to talk about is so there is a lot of excitement for humanoids development, and I want to talk a little bit about the next steps, right? How do you develop it and how do you also industrialize it? And what are some of the lessons that can be learned and shared from e-mobility industry? Let me just give a brief overview of who we are. We are FEV Group. We are present globally. We are about 6,100 employees. Our core focus has been everything from micro-mobility to advanced mobility, both small, large, and what we do see a huge potential for robotics, and especially humanoid robotics, and that is why we have started our own service area offering when it comes to humanoid robotics. We are focusing on a broad range of topics: business strategies, strategic advisory, technology advisory, as well as industrialization and integration. And we are not just starting as a service area, but we have been active in this service area for the past 1.5 years. And we have delivered multiple projects, both on OEM landscape, supplier landscape, especially. The thing that we are kind of proud of our supplier landscape is we have identified about a total of 600 different suppliers who can supply to humanoid value chain. And we have in-depth analysis and reports on supplier landscape as well as use case analysis. I will talk about our use case analysis in a minute, as well as benchmarking and target costing. So today, everyone agrees that humanoid robots are a pretty costly affair. Some of these prototypes are close to $100,000. So how do you design to value, or how do you design a robot to a target cost or to a target value? So that's a very, very important topic. And there's also, we feel, a very good area to learn some lessons from mobility industry. And as a part of our own demonstrator, we have been working with a unitary robot. We are working on use cases, humanoid use cases, picking, packing. So all of these are different, and a lot more. So we have a dedicated lab where we are developing use cases with our own humanoid robot. With that being said, I'll come into the meat of the topic. I won't spend a whole lot of time, but most of the people who are here do realize what are the key advantages. What are the key advantages of humanoid robots? You do get a lot of task flexibility, which you wouldn't get with a traditional cobot. You also have the advantages of scalable physical AI, compatibility with human environments, as well as human interaction. Whereas your traditional robots they're pretty much task specific, mostly stationary, and we see a lot of cobots today deployed in industrial automation. Whereas with humanoids, you get that added advantage of multiple degrees of freedom. And these are more generalistic or more general purpose robots, as opposed to being a more task specific robot. Now, what are some of the growth drivers? There are decreasing component costs as well as advancement in AI. We have seen a lot of presentations in the past 24 hours from a lot of presenters. The thing that I think I was pretty impressed with the Google DeepMind's presentation in terms of what their Gemini can achieve. So there are advancements in AI as well as sensors, which is pushing the boundaries of what these humanoids can deliver. Combine that with the market use cases. There is a significant labor shortage across different segments of the industry, and there is a need for high level of automation. Labor shortages, in order to work around it, but the best way is to increasing a higher automation, as well as cross-industry applications too, right? I mean, it's not just one specific task, but these robots could be deployed to address multiple different industrial sectors. With that being said, as just like any other new technology, we do expect that there will be a hype cycle. Even humanoid robot industry will go through a hype cycle. There will be a peak expectations which will result, and then it will go through a trough of disillusionment. And what we want to get to is that slope of enlightenment and plateau of productivity. And in order to do that, in order to be competitive, when you get to that point, is to prepare for, how do you prepare for the right, am I considering all the right regulatory scenarios? Am I considering all the right safety use cases? So that will be a key thing to successfully navigate the hype cycle and be competitive and be positioned as a competitive player. Now, especially after what we see is the market will pick up. I mean, at least there will be a significant demand post 2035. We do revise our own humanoid market forecasts. We do focus on 9 different key industries: manufacturing, warehousing, retail and commerce, household, elderly care or healthcare, construction, defense applications, agriculture, and mining. So right now we are covering about 9 different key areas of humanoid deployment. And the top 3 cases are obviously going to be household, manufacturing, retail, and consumer services. But our forecast, we do revise these forecasts on a quarterly basis, depending upon a lot of observing and analyzing industry activity, as well as our own interaction with these humanoid robot companies. But the key thing is, what we see is there is a significant demand for humanoid robots, especially the market will definitely pick up after 2035. Now, what are the challenges? So there are multiple challenges in order to successfully cross that hurdle. There are technical challenges. I won't harp on data for AI training. I think that has been talked quite a bit about, so I wouldn't touch that. But think of talking about the other topics, right? Supply chain. So what is identifying or developing or having the right supply chain for humanoid robots? And then obviously the topic that I want to talk a little bit more is industrialization. So how do you scale from prototype to mass production and industrialization, especially coming from a startup phase, right? And then there is legal and safety frameworks that come associated with it, as well as social acceptance. And then, of course, there is requirements, test criteria, which is not yet defined. But what does this lead to? There are a lot of unsolved challenges, but these unsolved challenges can be a very good entry point for tier ones and OEMs to define that entry strategy and leverage the existing know-how and experience. Now, today, most of these humanoids are limited to either prototype or a work cell. Now, in order to navigate from this kind of a environment to move into more of a cooperative and much further down the lane collaborative approach, there is a significant challenges um, to move, especially both from a regulatory, or both from a safety perspective, as well as identifying those rules and operational perspective. Now, there are, and the reason why I wanted to bring this up is there are industries which have successfully navigated this challenge. Autonomous vehicles, today you see, I mean, compared to 3 or 4 years ago, or even a year ago, you see a ton more of Waymos on the road rather than what you have seen even a year ago. So there are a lot of there are a lot of industries which have successfully navigated it. Autonomous vehicles is one, unmanned aircraft, drones is one, driverless trains, as well as cobots. So there are multiple use cases or industries which have navigated this. And I do want to focus a bit more on autonomous vehicles. Why autonomous vehicles is a perfect example. One, there are there are safety related challenges which have been navigated, especially with functional safety. So how do you handle functional safety? How do you handle a hazard or risk environment? When especially operating alongside humans. So that is one, regulations. And then also the approach, the technical approach to solving these challenges, a systematic, technical-based approach. So Cisco core systems engineering, any of the automotive folks would agree, it's a core systems engineering-based approach. So identifying hazard and risk analysis, as well as, so that would be coming from a functional safety perspective, but if you're coming from a cyber security perspective, because all these humanoids will be connected, that would be a TARA, T-A-R-A, threat analysis and risk assessment, hazard analysis and risk assessment, scenario-based testing, simulation, safety monitors, fallbacks. So all of these are some of the approaches which have been taken by autonomous vehicle industry to solve this challenge. And I'll just give it two examples. I'll go a little deeper into two examples. The first one is autonomous vehicle safety framework. What has been done? Hazard analysis and safety framework, hardware and software in loop simulation. We had a presenter from yesterday who talked about how do you use simulation to make your approach more faster. So that would be your hardware or software in loop simulations. Close track testing. So that is where you test it in a more controlled environment, then move on to deployment area assessment. So how do you scale from a closed loop environment to a much more enlarged environment? And then, of course, it comes to cybersecurity, public and road testing. And there are well-defined standards. And this has been talked about in the past 24 hours, is there is a need to identify or to come up with regulations and safety standards. But what can be learned or what can be anticipated at this stage is humanoids will be set, or at least they would be graded against a similar set of regulations. So this, at least understanding what is the regulatory framework for autonomous vehicles, so what can I expect for humanoids? So that would be a good lesson or a good takeaway. And then the other thing, electric vehicle framework. So why do we say electric vehicle framework? Because the industry has successfully navigated towards a more battery electric vehicles, which dealing with a lot of challenges. Thermal runaway, thermal propagation, which is a big challenge for EVs, and EVs have navigated that quite successfully. Now, these humanoid robots, these are not something like a 500 milliamp or even a 200 milliamp hour battery cells. These are anywhere from 1 to 4 kilowatt hour battery packs. So you do have to consider thoroughly what is the use case, what's the right chemistry, what are the right thermal management approaches that it needs, what kind of a battery management system do I need, as well as what kind of a charging approach. Is charging the right approach, or is battery swapping the right approach? So there are a lot of examples from China where on passenger vehicles and even commercial vehicles, both charging as well as battery swapping has been developed. So what's the right approach? What's the use case? What's the duty cycle? And then one thing which is, which hasn't been talked quite a bit, which hasn't been talked in humanoids is recycling. So how am I going to approach recycling, end of life? So there will be a ton of batteries. So am I designing my packs, not just the battery pack, I mean, it kind of extends to the entire humanoid robot, right? How am I designing humanoid robot for design for recycling? So all of these considerations need to be factored in. It doesn't just end at safety and regulatory framework, but in terms of, I mean, when you compare mobility industry to a humanoid industry, the parallels, there are a lot of parallels when you think about it, in terms of your vehicle software platform, software stack, sensors, sensor fusion, systems actuation, energy and power management. So there are a lot of similarities. So there are a lot of lessons that can be learned and successfully translated, extrapolated to fast track humanoid development. Now, as to summarize, right? So what are the key lessons that can be learned? One, autonomous vehicle framework. So this is a key system where you can think of you can think of redundancy. So how am I making fail-safe or fail operational designs? So these are some of the key things. And electric vehicle framework. I mean, how am I designing my battery system? What's the right energy density? What's the right BMS, thermal management system? How am I considering thermal runaway or thermal propagation? Am I considering recycling? And then components, right? Designing low-cost component frameworks. Is EtherCAD the best, or is that the only approach, or can there be a different protocol for handling low-level network communications? And then especially looking into engineering plastics, materials. There have been a couple of questions over the past day and a half about how do we lightweight these materials. And especially automotive industry has navigated those challenges, especially reduction in weight means extended EV range. And the development or systems engineering based approach, right? Managing requirements, design for failure modes. What are the failure modes? What are the adopting simulation-based testing, simulation-based approach, as well as a software V or a V model. I'll talk a little bit about that later, but as well as design to value, design to cost management. And then the final thing, while the industry is not there yet, but it's good to be thinking about it, is design for assembly, design for manufacturing. You can design a prototype which looks great, but is it easy to assemble? So that's the place where you can achieve scale and magnitude, as well as statistical process and quality controls. So how are you looking at, just as an example, Six Sigma process control, right? What is your distribution? Are you looking at how many deviations are there in is your process repeatable? Are your manufacturing process repeatable, scalable? So all of those challenges, right? There are things that can be learned. So as some of the key takeaways, so identifying a regulatory roadmap. So be proactive, be a part of a consortium, identify what are those regulatory roadmap is going to look like. To derive those test cases. And something what we've been doing at FEV is that developing those use cases, developing those test cases, and then thirdly, identifying safety cases. So how is the safety? Looking into, which kind of goes along with it, looking into HARA as well as functional safety, FUSA. And as well as identifying ecosystem-wide stakeholder management early on to design for cost, value, as well as design for manufacturing. So identifying those bottlenecks, or at least with a much more wider engagement, you can proactively approach design for value, design for cost, as well as design for manufacturing. And then integrating some of these safety monitors directly into hardware as well as software stack. So, and again, the thing that I was talking about as a software V model. So when you look at, when you start with requirements, start with requirements at the topmost level, break it down into system design, break it down into architecture, component, and validate it. So develop your requirements, implement it, and validate it at each and every stage of the design. And we, at FEV Consulting, we are active in almost each and every stage of the V model, both at designing to value as well as developing those use cases, requirements definition, and supplier identification, developing those procurement strategies, as well as validation testing, and then safety, safety evaluation and assessment. I'll just leave with this. So there is a huge, we all agree, we are all here, we all agree that there is a huge value chain is going to be developed. And there are opportunities, not just for humanoid OEMs, right? There are adjacent opportunities for a lot of automotive communications, a lot of other companies. There is the pie is big enough for a lot of other companies, who are not directly operating in humanoids per se, but to move into an adjacent market or to grow into an adjacent market. So with that, if you have any questions, yeah, I'll be outside. Feel free to get in touch with me. Any questions? Yeah.
Thank you so much, Prasanna. This was very interesting. Please give him a big applause. Thank you. There is no time for questions, as he mentioned, but he's going to be here aside, and he will be happy to answer anything to you.